Assalamu alaikum again. This is me again, Khalil Al Houthi. I finished answering or guiding you with question number one. In this video, I tried to finish both question two and three. I don't want to make it short. If I find myself exceeding the time limit of 20 minutes, I might stop the video. So we solved for question one. Let's solve for question two. In question two, we have two different rock samples and we keep exerting vertical and horizontal forces. So in this case, for example, in sample one, when we exert uh, a vertical and a normal forces as shown in here, the rock will break. If I increase the horizontal force, then I need more vertical forces to again make a fracture in the rock sample. So that's what's exactly happening. I'm increasing the horizontal confining pressure or force. So I need more vertical force to make a fracture. They're going to be right now, again, three different Mohr cycles. We need to plot them for sample one and sample two. So if we have our first equation, that's the one, or first function in Python, let's copy it. To draw circles, we need the radius and the center. So how to get them back to these slides? We need sigma 1 minus sigma 2 over 2 to give us the radius. Sigma 1 plus sigma 2 divided by 2 gives us the x and y center. Oh, sorry. It gives us the x center. Y center is 0. So let me modify this equation, name it circle. We need only sigma 1, sigma 2. We don't know what's theta. And there are no more uh, stresses. We need to get then center x. Center x is basically what is this value. Sigma 1 plus sigma 3 divided by 2. And center y is 0. Finally, the uh, radius is what? Is this value. Sigma 1 minus sigma 3 divided by 2. Let me retain these values. The first one, I combine them together into a bracket, name it center underscore x, center underscore y. These are the return value. I'm returning this one and this one. And again, another comma. The next value is the radius. Radius. This is exactly the value you see here. I run the cell. They have the equation ready or the function ready. It needs two inputs, sigma 1 and sigma 3. Let's get the input and see what are our return values. I go back here for sample 1. Let me make them into two different screens or split my screen. In this case, I have sigma 1 540, sigma 3 is 40. Oh, I mistyped here. Center X, center Y. Run it again. This is my the point or the center of the circle, and that's the radius. Let's go back. Start drawing. Where is it? Here is it. A circle. Let's make it. The radius was. I keep forgetting what was the radius. It was 250. 250. And how much was the center? That's the center. Let me copy it. Come back here. Instead of A, I just type its value. And the A, I can delete it. That's the first circle. Let's do the same thing for the next circle. My forces are changing. The vertical and horizontal forces are different. I have it 650 and 150. The same. The radius haven't changed. The center has changed only. So I make a new circle again. Circle with radius. This is 250 and change this one, the center point to whatever value I obtained. That's the one. Let me delete this random point. The second one. Finally, that's gonna be the values I have as 900 and 400. The radius haven't changed. The center point has changed. The x-axis of this center point is 650, while the y-axis is 0. Let's plot it here in this. And that's 250 radius. Perfect. So that's it for question 2, part 1. There is another part, sample 2. But you need to have this drawing. You need to have this drawing for question 3. So question 3 says we need to draw a line of envelope. The filer envelope is the tangent line to the Mohr circle for critical stresses. How to draw it? Just draw a line. That's the line. I draw this line. I try to make it as bad. It's 250 exactly. Let me see where 250 is. Yes, that's the line. This is a line. So you know what's the equation of line. The equation of a line gives you the intercept, the y-intercept. We already know what's the y-intercept. It's 250. And the slope. The slope in this case is 0. The slope itself is 0. To confirm that the slope is 0, we can actually do things in Python itself. Python is very powerful. So that's my envelope line. The thing you see above is the envelope line. That's what we call the envelope line. Getting phone call. So let me help you here uh, how to exactly get the slope and the intercept. I do what? Import a library called SymPy. That's SymPy. And I define two variables. One is x, the other one is y, equal what? SymPy, the library symbols. These are symbols. And one of them is, sorry, x and y. X space y. So I have an expression. This is the equation of this line. That's the equation. I name it expression. Expression equals minus 1.13 times x. This is the x, the variable, plus 777.99 times y. And I need this variable to the other side to come to one side. So it becomes an expression. The expression is equal whatever you have. So This goes to the other side. It goes to the other side and it change its sign. It becomes 194496.94. This is basically an expression. Let's see how it looks like. This is the expression. That's my expression. I need to solve it with respect to y. To put y in one side so I exactly see what's the intercept and what's the slope. So if you try to solve it, you might go into the problem. Let's see how it looks like. Simpy dot solve. That's the function I want to solve for this expression with respect to y. That's the y. Let's see what happened. So that's the slope and this is the intercept. The slope is nothing. uh, it is zero, but I haven't drawn it perfectly. That's the reason it's not showing as zero. Let me try to make it more perfect. So you see, it's not perfectly along this line. So what I do, I can change the values of A and B to make it more accurate. So the x value of A is 0, that's A, and Y is 250. For B, I can take any value, but the Y is supposed to be exactly 250. That's the reason it's not a perfect horizontal line. 250. The X can be anything along that line. So it's changed slightly. So let's see. Yeah, it's the equation itself changed slightly. So let's see my expression. How much is it? 77.9. Yeah, because there is some like rounding errors. So in this case, I just assume that this is basically zero. The slope itself is zero. And the y-intercept is not the one you see here, is at 250 exactly. There are some rounding errors. As I said, in doing mathematical things, you always get into rounding error, especially since we are using this tool. This tool brings some rounding errors. So that's my line. That's what I need actually from this thing. I have the forces. Let's drag this one a bit outside. This is the plot you need. I bring the label here. I take a screenshot. This is a new screenshots. This is the envelope line, the one you see above. Copy it, come back to the exercise. This goes here exactly. This is the location of or the answer to this question, this part. That's how is it. And we go for this part soon. But before that, let's solve for this one. So where is the shear stress? Sorry, what is tan theta? Mu is zero. The mu is zero. The slope is zero. So get me what is determine tan theta. What is slope is already there. Slope is sorry zero, and intercept is 250. So you need to determine what is theta. What is theta using this equation? That's the equation you use. You need to determine the friction angle from here. Tan theta is equal to mu, which is the mu itself is 0. Inverse of tan, inverse of mu will give you inverse of tan 0 will give you this value, this angle. So you can plug it here. And finally calculate what's the theta. You are asked you are asked to determine what's theta. This was for example 1 or sample 1. We do the same for sample 2. So let's do it for sample 2 very quickly. Sample 2, I might delete this line, delete this point, delete as well the A. And again to my notebook. Where is the notebook? Uh, that's the notebook. So again, I use the circle, but I have the variable as different variables right now. I need my question sheet. Circle in this case is the first one is 550, 14. Nothing changed for that first circle. Same as the first sample, both of them as 40 and 540, 40 and 540. In here, it's gonna be 800, while this one is 150. So this is 325. Let's change. Uh, let's change the second circle. That's the x-axis. It was 325, I believe. Double check. Yes, this is the second circle, and the final circle again for document final circle gonna be 1400. 100. And the radius is 500 and the center point is 900 0. So I modify this circle. This is the radius is 500, whereas this one is 900 and 0. Okay, is there something wrong? Yes, here this one's supposed to be 325. This 325, I think there is something wrong. Let me double check. Double check my variables. Yeah, let's me do them one by one. I think this is 400, 100. That's perfect. The second, this is 540 and 40. Yeah, 290 and 25. The middle one is 800 and 120. Sorry, 150. Uh, it's not this one. This one with the notebook. So circle C is circle C is 290, 0, 250. That's perfect. Circle E. Circle E is off. That's, I think this, yeah, it's 475. 475. Yeah, this is correct. Right now it's fine. hmm So we need to draw a line tangent to these three circles. Again, I go here, a line. I try to draw it somewhere from here, and it becomes tangent to these three one. You cannot be very perfect. In mind, it's not perfectly touching all of them, but we try our best. The more accurate you are, the better it is. So I might need to change the value of A, make it a bit lower in the y-axis. Uh, make it a little bit lower, maybe 0, 30. Too much. Mm-hmm. 0, 2, probably. Won't be very perfect, but we try our best. Maybe you can come up with a better idea how to draw this line. Nevertheless, if I go with whatever I have, this is the equation I have. The equation is there. As I said, it won't get very perfect. It looks like touching all the points, but let's go with what we have. Again, I come back here. I use another expression. I create another expression. I name it expression 2. So expression 2, I have this value for the x is minus 417.55, 927.9, and finally minus 133,899.32. So this is expression 2. Shift enter, then we solve it the same way we solved here, but we solve it for expression 2, we solve it with respect to y. So this is the slope, and that's the intercept. Just take a screenshot of this one. Copy it, bring it to the question sheet, paste it down here. So what the intercept and the slope for the second sample, sample number 2. These are the question you are asked to solve. What's the intercept, which is t, and what's the slope? And from the slope, you can use this slope, get this value, plug it in here in this equation to get the value of theta. Finally, you need to sketch something similar to what you see here. Sketch a box to what you see here. Um, you are given actually what angle you are given. The angle, if I can draw somewhere here, can I draw here? Yes, so this is a box. So theta is basically this angle. Theta is this angle. The theta you get from here, that's the theta, it gives you this angle. How to calculate then the horizontal angle? Is theta minus 90 or 90 minus theta. 90 minus theta, whatever theta you get, gives you the horizontal angle, the angle of fracture. That will give you the angle of fracture. At what angle the fracture will happen for those two cases, this case and the other case. Good. That's the last thing. I will stop record and send this video to you. Goodbye.